Thanks for coming tonight. I'll be speaking to you about some of the things that AI can be applied to for public good, right? So just recently, first, I'm Aivin Solatorio again. I work at Caliber, and I'll be discussing to you some things about AI. So first, what's artificial intelligence? Artificial intelligence has been around since like 1950s, and it has evolved and developed from 1950 up to the present. And there have been phases where it became more known as machine learning, more specialized, and up to the recent years, it has become, well, the more familiar AI form is deep learning, right? And that's primarily due to the availability of large data sets as well as large available resources for computation. Some of the fields revolutionized by AI in the recent years are the following. So we have a lot of milestones achieved in computer vision, speech and audio recognition, and natural language processing. For example, things that you've been using with Google, for example, at the back end of it utilizes AI. And now, we can think of AI as a tool or like a paradigm at which we can solve different problems. So how can we apply AI to predicting poverty? So first, we need to know that poverty is a very crucial problem that the world is facing. For example, the World Bank defines extreme poverty as living with less than $1.9 per person per day, right? And it says that 767 million globally lives below the poverty line. So what does that mean? In perspective, it's like by buying a venti-sized Starbucks, you can already like provide for 2 persons living in the poverty line. So it's if you think about it, it's very, very big problem. So we don't need to look far. Poverty is here in the Philippines. In 2015, the National Economic Development Authority released the statistic that 21.6% of the Philippine population lives below the poverty line. Well, while it's a relatively high number, in fact, it was an improvement from the statistic since 2009. So the trend has been decreasing, but the absolute percentage is still high. And we hope that by, say, for example, using AI and some other analysis, we can help guide our, say, policymakers to drastically reduce that number. Poverty incidence is a declining but a prevalent problem. So we can see here that since 1990s, the decrease in poverty incidence had been very, very large, say for China, India, and some other Southeast Asian nations. However, for most of the sub-Saharan nations, the difference between what was before and what is in the present is still minimal. So the World Bank, like a few months ago, started a poverty prediction challenge. They hope that by having better models, they can properly address certain problems with regards to poverty, especially in terms of targeted policy making, as well as allocation of proper resources to poor communities. So we can now have an idea of how machine learning can be. Well, at first we might not know how machine learning can be used to solve poverty, right? But to start with, I just want to share with you how like machine learning is working. So machine learning works by so it's an idea at which an algorithm can be written in a way that no human intervention or like specific rules is needed to train a model. So for example, in that particular graphic, you can see that the condition boundary varies over time, but at the end, it is able to like maximize to properly distinguish the red and the blue line on its own. So imagine a person manually like telling the line to distinguish a black and the blue. But with machine learning, we no longer need to have that manual intervention. It's just that it learns from the data itself how to differentiate between the blue and the red data points. And so for the competition specifically, I hope, so I don't think that the problem is quite hard in a sense because it's very like intuitive. Poverty can be measured by some form of instrument. For example, by conducting surveys, you can try to understand how a poor household looks or is different from rich households, for example. So the data was based from household level and individual level surveys gathered from 3 developing countries. So these countries are unknown. The data were obfuscated. So the problem of the competition is that the second point, the data is obfuscated. As you may know that one of the biggest thing that you can do in a machine learning problem is feature engineering, right? With feature engineering, you can probably drastically improve the performance of your model by like combining relationships between 2 or more features. But for this problem, it's very hard because you don't have any prior information about the kind of feature or data that you're working with. So that's one of the problems. And thirdly, the metric that was used is to optimize this particular equation. So it's the mean log loss. So as you can see, it's like penalizing the model every time it makes a mistake, and it penalizes a lot if it makes a large mistake compared to like minimal mistake. So that's what it means. So overview of my solution. So eto medyo, this is a bit of technical already. So I hope this serves as a like starting point for you to try exploring machine learning. So the idea here is that the strategy that I worked with is the goal is to blend the different models. You can't work with single model only in machine learning competitions, right? It's like you surrender if you don't combine different models. And that's the idea. By combining different models, you can try to even out noise in your predictions and come up with a more like robust set of predictions for your, say, data set. So the idea is I combine these base models, perform Bayesian optimization and cross-validation, and finally perform a blending. So let's go to the specifics of each of the items here. So first, logistic regression. I think it's very relatively basic in a sense that logistic regression is like a fundamental machine learning algorithm that everyone starting with machine learning should know. So I used logistic regression with L1 regularization in particular because the data set is relatively small compared to the absolute number of features. So it's very high dimensional, and by using L1 regularization, you try to encourage the model to find the optimal solution with the sparse solution set. So that's the idea. You can't, I mean, by applying L1 regularization, it's like less is more. So you're like the model tries to find the best minimal set of features that can provide the largest possible improvement in your prediction. So second is the random forest. Random forest is an algorithm based on decision trees. So for example, you have 4 decision trees. Each of them are trained on a data or subset or random sample set of the data, such that each of your decision tree can predict an outcome of a data point. But the advantage of a random forest over decision tree is that it can reduce the bias of your model, well, the variance of your model. You can reduce the variance of your model and make it more like robust in a sense, and it prevents overfitting. So overfitting is the tendency of your model to like perfectly understand the training data, but when the time comes that you input data that it hasn't been trained on, it starts to fail. So as you can see there, the distribution of each different forest varies a bit, but when they are combined, it maximizes the likelihood that a certain class, like the gray class, is being predicted. So boosted trees. So boosted trees is one of the well-known algorithms in machine learning competitions. So I used XGBoost implementation and LightGBM. So LightGBM is an implementation from Microsoft. Again, it starts with a decision tree. So you have a decision tree, but the difference between gradient boosted trees and the random forest is that for random forest, you try to grow independent trees, whereas for gradient boosted trees, you try to iteratively grow trees based on previous results of your model, of your trees grown prior to it. So for example, in your first boosting round, you have a tree up there with a set of predictions. Then for your next boosting round, you grow another tree that minimizes the residual or optimizes the residual of your prior models, and you try to go on until you come up with a stable solution for your problem. So what's the difference between XGBoost and LightGBM? It's just the difference is the way at which the trees are grown. So for XGBoost, it's level-wise. So you first try to split all your data per level, whereas the leaf-wise method for LightGBM is a bit fast because it tries to grow the trees up to the bottom by node first. So it grows first here, then the succeeding iteration would grow the node to the bottom. But take note that XGBoost has implemented almost the same algorithm with LightGBM, so they've adopted a similar concept in their own package. And lastly, I've used neural network as well. Interestingly, neural network on its own didn't work well with the problem, but by using it, it somehow was able to capture some nuance in the data as well, resulting to some improvement. So integrated it into the model. So so neural network and deep learning are two very buzzwords right now, but it's very basic in a sense that you just have stacked logistic regression algorithm. So sometimes deep learning algorithms are very complex, but for this particular problem, I decided to just use a basic feed-forward neural network because, why not? Because it's more robust. In particular, I chose it because it fits the kind of data that the problem is using. Well, you might ask, well, some of the experienced data scientists here would ask, why? So you only use those models? They're off-the-shelf models, etc. And yeah, but the idea here, the thing that I think are the secret ingredients to at least ranking high in the competition are these three. So if you think about it, these three factors here are commonly not discussed in depth in most, say, blogs, articles, etc. And you can only improve on this if you really work with your data set and try to develop models on your own. So first is the properly designed cross-validation. Second is a Bayesian optimization. I use that, and the third is a blending algorithm. So the secret sauce one, properly designed cross-validation. So it's common for people to use cross-validation or k-fold cross-validation, etc. But at the end of the day, you might encounter some problems with it. So that's why I went with the double cross-validation strategy. It's not common, so I want to share with you how it's done. So for the double cross-validation, you can do it this way. So first, you have a full training data. So that's different from a test. So that you have a test in the training data, and given a full training data set, you first partition that into J-folds, right? Then you perform a cross-validation, but done somehow differently, because after you take the J-1 partition, you can set that as your first outer training set. And when you have that outer training set, you then use k-fold cross-validation. So to partition your initial outer set. Then after you have that, you then perform the standard cross-validation technique. So it's like so you have the k-fold cross-validation, you take the k-1 folds, you train the model, you predict the first inner validation, then you do that for all other folds. The difference here is that you use the inner fold or cross-validation to optimize the model, but you need to look at the first outer validation data as your synthetic test data set. That way, you will guarantee that you solve the data leakage problem, which is very prevalent in most machine learning algorithm. For example, I've seen a lot of work that they report very big improvement in their model, only to find out that they used their own training set as the scoring data. So that's one of the obvious data leakage problems. So you never try to predict or to validate your data or your model with data that was used to train the model. Okay, never. That's one of the biggest mistakes that you can do in anything that related with machine learning. So any machine learning project, any machine learning product, any machine learning competition, never be a victim to the data leakage problem. So while it comforts you that you have a very good score, at the end of the day, it will bite your back. Because when you deploy it to your system, it will drastically destroy your metrics. So by doing all of these steps, you will be able to guarantee a robust model, and it will help you make or at least boost your confidence in the result that you're getting. So I would like to advocate this level of rigorousness in cross-validation in training your models, because it's really helpful. The next part is the secret sauce number 2, which is Bayesian optimization. So right now, it's relatively uncommon to use Bayesian optimization, but the idea is that Bayesian optimization simply utilizes Bayesian inference such that it helps you find the best parameter for the model based on the prior predictions of your model. So as more predictions your model make, the more accurate the kinds of parameters that the Bayesian optimization procedure try to give back to you. So although it's a bit resource intensive, but theoretically it provides better parameter set than the grid search or the random search. So with Bayesian optimization, you don't need to exploit all other places where the model or your optimization function doesn't make sense. So as a visualization, it looks like this. So the top two figures are the points of interest. So yung top right corresponds to the target function, and at the left part is the expected result. So as you can see, yung density or the redness and the blueness corresponds to the points at which the Bayesian optimization algorithm sample the parameter set. Right? So for example, nagiging almost similar na yung target function mo and the predicted mean. So if you look at it, it's like trying to avoid spaces in a blue. On its own, it tries to learn that I won't give you a set of parameters on the blue region because the loss function there is not okay. However, it will try to give you more of the parameters in the area where where the optimized set of parameters is located. For example, yung mga red regions mo. So if you can see yung mga what you call this, the density of the sampled parameters lie in the hat area. So it's very smart, but it's relatively resource intensive. Pero relatively, compared with with random search and grid search, I'd say you just try to use Bayesian optimization. And the last ingredient is the blending algorithm. So there are different kinds of strategies that you can use to combine different models. One is stacking, the other is blending, the other is stacking and blending. So I implemented my own like blending strategy. And the advantage of it is this: for common blending methods, it's very hard because the idea is you set the weights somehow educated but relatively arbitrary. So it prevents you from scaling the number of models that you can use in prediction. So the idea kasi of blending is this: you have different models. You want to combine their predictions such that you come up with a hopefully better prediction, right? And you can do that by weighting their predictions and hoping that your weights are accurate. Pero manually assigning weights is very hard, especially if you have 3 or more weights. So this algorithm, I think this is one of the innovations that I've come up with during this competition, where I was able to realize that you can make a blending algorithm that's automatic, in a sense that you can optimize a linear problem that can help you arbitrarily scale the number of the base models, as well as it serves as a more principled approach in combining different models. So, pakita sa yung code. So, it's in Python. So, as you can see, it's a very straightforward implementation. I just use an optimizer algorithm, so yung first parameter is the unsummed loss function ko. So, the function is defined somewhere. Pero imagine niyo na lang yan yung loss function. And yung second parameters are the constraints. So, I need to make sure that the solution of the linear optimization is that the weight should sum up to 1. So, para, reasonable yung weighting. So, to visualize that, it looks like this. So, for example, yung curved thing mo is your loss function, and your plane is the optimization constraint. So, wherever that two intersect, yun yung mga possible solutions ng optimization problem mo. So, that's the intuition of how the thing was solved. So, as you can see here, arbitrary lang yung size ng model. You can add as many models up to 1,000, etc. And you'll try to solve on its own the best parameter weights for your blending algorithm. So, yan. So, actually, yun lang yung solution ko. Relatively straightforward, but with all those, I think there's one lesson that I want everybody to think about, which is always make sure that you don't overfit. You don't overfit. Overfitting is your worst enemy. As you can see here, hindi ko alam kung clear, but all of the other participants, yung absolute difference of their public to private leaderboard is around 0.0025. However, these two, more than 0.003, and sadly for the person, yung EdSu2, he should have been a third placer, but because he overfitted his model so much, or their model so much, he drastically went down in the ranking. So, kaya yun yung sabi ko na, I would go with cross-validation, with a double cross-validation, para ma-prevent mo yung problem na yan. Na you feel confident, at the end of the day, you failed kasi you did that. You did not properly cross-validated your model. So yan. Medyo ubos na ako sa oras, but I'll try to make this fast. Yung second kasi is more on AI-assisted search. So ano yun? So it's about us. So Caliber. Caliber kasi, we're like a matching platform. So job matching platform. And we think that we're helping the community to find better jobs. So what we do at Caliber, so my team at Caliber, we're focusing on research and development. And we live by this mission. Our mission is to make humans do what they do best, which is to build and to nurture relationships. So unlike the common anecdote about AI, which AI might replace jobs, etc. At Caliber, we want to change the paradigm, wherein we want to place AI as AI as one of the components that can help you find jobs instead of AI replacing your job, right? So how are we using AI to help everybody find jobs, or for recruiters find the best candidate, right? At Caliber, we have been doing a lot of these things, NLP, recommendations, algorithms, information retrieval, graph theory. So I think these are the things like Carl mentioned earlier, the kind of models that you need to understand. It's not the logistic regression, the random forest, etc., but it's the field at which you can frame your problem into. So for example, an NLP, you can like fit a lot of problems in it and try to solve a vast variety of problems by understanding how NLP models work, etc. So in a more concrete sense, we've applied those models into these particular problems: job matching, candidate matching, and text parsing and understanding. So I think it's like you open your phone, you find, because you viewed this job, etc., you can see jobs similar to that. So it's like watching over Netflix, you get recommendations, etc. That's what we do at Caliber. So it's not cool, right? It's not cool because other people are doing that. But what's different is that we're trying to incorporate a lot of technology in it, such that, for example, we have this job title clusters, and this corresponds to, each point there corresponds to a job title. And we didn't tell the model what the titles are like related to, but we were able to devise or to structure an algorithm which was able to learn relationships between job titles. So at Caliber, we have this technology. We haven't released this yet, so kayo yung una nakakita nito. So, wherein for any given job description, we can tell which things in your job description are relevant. And what's interesting here is that these are all automated. We trained a model to capture that information. So I think, I think nobody has done this here in the Philippines. So, but this is based on how popular the skills or the tokens represent the person. However, what's interesting is that we can condition the model to look into different parts of the same job description that aligns to the condition. For example, earlier, that's like the summary of the job description. For this, we conditioned the model to look at like the same job description, but with the database concept in mind. So with that, we can see that it highlights terms like CRUD, create, read, update, delete. It highlights SQL or database technologies. It highlights database and data handling systems, etc. And this is the kind of technology that we're developing at Caliber. At the same time, if you think about it, this is our way to make sure that our AI works as expected, right? We don't want to make our AI a black box. We want to make our AI as expressive as possible and as reasonable as possible, right? By doing this kind of thing, we make our AI more transparent and make its decision-making more obvious to people. So that's the kind of technology that we want to like do at Caliber. So